In this session, we shall go through some more special problems in general solutions of trigonometric equations. Consider the problem which is available directly on the board. The number of solutions of the equations. One equation is x plus y is equal to 2 pi by 3 and cos x plus cos y is equal to 3 by 2. The solutions which satisfy both these equations. How many such solutions will exist? Of course, in the closed interval 0 to 2 pi, we need to have. Let us try to solve. Look here, cos x plus cos y is equal to 3 by 2. Isn't it? So, what is cos c plus cos d? 2 cos c plus d by 2 into cos c minus d by 2 is equal to 3 by 2. But x plus y is 2 pi by 3, isn't it? Cos of 2 pi by 3 by 2 into cos of x minus y by 2 is equal to 3 by 2. 2 pi by 3 by 2 means 2 gets cancelled. What will be left here? Pi by 3. What is cos pi by 3? Half. 2 into cos pi by 3, 2 into half. So these two will be cancelled, leaving you cos of x minus y by 2 is equal to 3 by 2 and 3 by 2 is greater than 1, and it is foolish to observe. It's impossible. Can the value of cos x minus y by 2 be greater than 1? It can never be, which is impossible, which is not possible, which is not possible. Therefore, how many solutions will exist here? Simply 0. No solution at all for these two equations in common. Therefore, the number of solutions is 0. That's it. That is about the question. Another question is before us. It's a beautiful question. You follow the question carefully. Exponential of sine square x plus sine power 4x plus sine power 6x plus etc. up to infinity into ln 2 is a root of y square minus 9y plus 8 is equal to 0, then cos x by cos x plus sin x is, of course, when x lies in the first quadrant, that is 0 less than x less than pi by 2. Well, first of all, let us simplify this expression. What is that? Sine square x plus sine power 4x plus sine power 6x. You can observe this is a geometric series whose common ratio is sine square x is less than 1. Why should it be less than 1? Because x lies in the first quadrant, 0 less than x less than pi by 2. Therefore, sine x is less than 1. So, sine square x is less than 1. Hence, the ratio here in this geometric series, the common ratio is strictly less than 1. And you can be in a position to use the formula a by 1 minus r, isn't it? A means first term, r means common ratio. Sine square x by 1 minus sine square x is nothing but tan square x, is nothing but tan square x. Okay, e power tan square x into ln 2 is a root of y square minus 9y plus 8 is equal to 0, and you can write this equation as y minus 1 into y minus 8. It's very simple, and it is clearly visible that the roots of this equation are 1 or 8, either 1 or 8. But you see, this is a root of that equation. So this expression is either equal to 1 or equal to 8. So two cases will now arise. Which are the cases? E power tan square x into ln 2. What is that? E power ln 2 power tan square x is equal to 1 or 8. 1 or 8. What is e power? What is meant by ln 2? Log x to the base e, log 2 to the base e, isn't it? So this is tan square x. This is tan square x. Therefore, tan square x 2 power tan square x is equal to 1 or 8. Therefore, 2 power tan square x is equal to 2 power 0 or 2 power tan square x is equal to 2 power 3. How many cases will arise now? 2 cases. One is tan square x is equal to 0 or tan square x is equal to 3. Tan square x is equal to 3. Let us now simplify the cases and have the answer. From the first one, tan square x is 0, then x is n pi. X is n pi, which is not possible. Why? Because x lies between 0 and pi by 2 only. So this is not possible. Now you take that. Tan square x is equal to 3. Tan square x is equal to 3. So tan x is equal to plus or minus root 3. Plus or minus root 3. But x lies in the interval 0 to pi by 2. So tan x is equal to root 3. Tan x is equal to root 3. Then x is 60 degrees. So this is cos 60 degrees by cos 60 degrees plus sin 60 degrees. Isn't it? Therefore, these are all the various discussions that must be put in your mind directly. Well, my dear, if you can follow these steps for a little while, I would like to remove these steps to save some space to have the clear-cut answer. Case 1, tan square x is equal to 0. Tan square x is equal to 0 implies x is equal to n pi does not belong to open interval 0 to pi by. If you take n is equal to 0, then x is equal to 0. It does not belong to this. If you take n is equal to 1, it is pi. It does not belong to. So it's not possible. You just discard that case. And the other case is tan square x is equal to 3. Implies tan x is equal to plus or minus root 3. If tan x is minus root 3, then x does not belong to open interval 0 to pi by 2. So tan x is equal to plus root 3 is only possible. Therefore, x is equal to pi by 3. And if you substitute there, cos x by cos x plus sin x is therefore equal to cos pi by 3 is half by half plus root 3 by 2. If you can multiply with 2, it becomes 1 by root 3 plus 1. And if you get it to the numerator, it becomes root 3 minus 1 by 2. That is the answer. That is the answer for the question. The next question before you is, observe the question. Sine of e power x is equal to 5 power x plus 5 power minus x in the closed interval 0 to 2 pi. My dear friend, if you can remember one particular thing, without using pen and paper, you will be able to have the direct answer. Why? Because LHS is sine of e power x always less than or equal to 1. RHS is 5 power x plus 1 by 5 power x always greater than or equal to 2. Why should it be? Why should it be greater than or equal to 2? This looks like y by 1 plus y, where y is of course 5 power x. And from the knowledge of maxima, minima, or the knowledge of functions, you all know that y plus 1 by y can never lie between minus 2 and 2. Provided if y is positive, it can never be less than 2. Greater than or equal to 2, it is always. If y is negative, it will always be less than or equal to minus 2. So at any cost, as y is positive here, in the place of y, what are you having? 5 power x you are having. But 5 power x is positive, purely positive. For any x, 5 power x is always positive. Hence, y plus 1 by y, this is in the shape of y plus 1 by y, where y is positive. Hence, this is always greater than or equal to 2. How can you have a solution for LHS is equal to RHS? How can those two quantities become equal? So, it has no solution at all. Number of solutions is simply 0. Number of solutions is simply 0. That is the question. Another beautiful question is there. It is welcoming us. It lies on the board. Please look at that. The number of integral values of k for which the equation 7 cos x plus 5 sin x is equal to 2k plus 1 has a solution is. There are options given 4, 8, 12, 10 like that. Let us see. Let us first of all observe the left hand side. What is 7 cos x plus 5 sin x? We know that. What is the range of this? I think you might have remembered minus root of a square plus b square to plus root of a square plus b square. That is minus root of 7 square plus 5 square less than or equal to LHS less than or equal to root of 7 square plus 5 square. This is 49, this is 25. 49 plus 25 is root 74. Hence this is minus root 74 less than or equal to 2k plus 1 less than or equal to root 74, isn't it? Root 74. What do you mean by root 74? Root 74 is greater than 8 but less than 9. So it is 8 point something. So 2k plus 1 should lie between minus 8 point something to 8 point something. Well, you start. K is equal to 0. 0 plus 1, 1. Possible. 1. 2 ones are 2, 2 plus 1, 3. Possible. 2. 4 plus 1, 5. Possible. 3. 2 3s are 6, 6 plus 1, 7. Possible. 4. 2 4s are 8, 8 plus 1, 9. No. So k is equal to 4 is not possible. K is equal to 4 is not possible. If you take k is equal to minus 1, 2 minus 1s are minus 2, minus 2 plus 1 is minus 1, possible. Minus 2, okay. Minus 3 is also okay. Minus 4 is also okay. So altogether, how many possible values are there? 8 possible values are there. Hence the right answer is 8. So like that, you may have to make an attempt on such questions. A beautiful question it is. That's it. That is the answer for that question.